All right, hi everyone, welcome back. We're going to do another LP problem. This one is, I think, a little simpler than the last one. You could tell, obviously, it's just much shorter in terms of the text on the screen. Read the text if you haven't done so already, and then keep in mind this table here goes with the problem percentages. One thing just to note in this table, the numbers 5.3, 6.8, 4.9, these are all percentages. Even though the percent sign is not in the actual value. So this is 5.3%. All right, so read the problem if you haven't done so already. And as we do so, think about what is the objective, what are the constraints, and what are my variables. You'll see this one is a little bit of a play on the last one, more advanced, just a little bit though, but in a different direction. So pause the video, read the question if you have not done so. Okay, ready? Here we go. A brokerage firm has been instructed by a client to invest $250,000. Okay, right away you always are thinking about this one. What is my constraint? What is my budget? So you are now an investment firm. What are my constraints? We have a budget. I have 200 grand to do something with. We'll hold on to that for a second, but we definitely have a budget here. The client requests the firm select whatever stocks and bonds they believe are well rated, but with the following guidelines. Municipal bonds constitute at least 20% of the investment. At least 40% of the investment is placed in tech stocks, and no more than 50% are the amount invested in muni bonds. Should be in high risk. And if you look at the table here, we have HDN stock. This is your one high. So my question to you is, let's go back for a second. What are my variables? What are the things as a manager that I have to decide on? And then what is my objective? What is the thing that I'm after? So here I want to invest some money. So clearly I'd like to do what? Maximize or minimize this rate of return. If someone gives you money, should you maximize or minimize the rate of return? I want to maximize it. So notice that it's not explicitly in the question, but clearly that's what they're looking for. So we want our rate of return. All right, so let's back into this a little bit. All right, I know the rates of return. Now, they're all positive. So keep in mind that I'm clearly not giving you all information. This is like an average rate of return. Obviously, stocks can lose money, etc. Just given anything, I would throw all my money in HDN, right? Why bother with lower rates of return? But so the question is a little contrived. But if you do that, you're going to see you don't actually meet the constraints. So you're going to have to invest here. What I'm going to do here is I have to decide how much money of the 250 grand to put into each investment. And I have 1, 2, 3, 4, 5 investments. And this is where this problem grows in complexity. Last time we had a tricky situation where I had multiple parts going into my net profit. Right now, though, I have 5, count them up, 1, 2, 3, 4, 5 investments. And so as a manager, I have to decide, what am I going to put into the 5 investments? All right, so let's try that. So here we go. So X1, X2, X3, X4, and X5. Now, why am I calling it this? I don't want to type out LA Municipal Bond. I don't want to type out Thomson Electronics. I'm just going to call it X because, X is unknown. Seems like a good variable. You can call it I1. These are dummy names. Who cares what you call it? They just correspond to it. But here's the complexity of this problem that is different from the other ones. Now I have 5 decision variables instead of the 2 that we've seen prior. So that's our first thing to realize. Now, we have to figure out the rate of return. And remember, the table is a percentage. So maybe I'll put in the percentages somewhere else right below it. So how about 5.3? And I'll just do percentages here so I don't really have to worry about it. 5.3%, just make sure I copy these correctly. 6.8%, 4.9%, 8.4%, and 11.8%. Great. So I'm going to put in some dummy numbers here, just to make sure that my spreadsheet is actually working. So I'll put in, hey, $5 across the board. Clearly that's not the right answer, but it's just there to help me out here. So what is my objective? What do I want to do? I want to maximize the rate of return. So if I invest $5 in the first one, LA Municipal Bonds, well, that's going to be a rate of return of 5.3%. And then I would add that to the rate of return for each individual investment. So my rate of return, my objective here, the thing that I actually want to maximize, the gray cell, is going to be what? Have you figured this out yet? It's the sum product of each investment, comma, with their returns. Interestingly enough here, what is this number? This is not actually my rate of return. This isn't a percentage. This is the dollar amount that is returned. So if the first investment makes 5.3%, well then I made, and the other one makes 6.8%, I've made, once you do all of them, $1.86. So this is actually a number. This is actually a dollar amount. So I'll put the formula text here. Okay, so that's our formula. That's what we want to do. So now let's go through the budget and the constraints. So let's build out my constraint table. So let me move some things over, because remember how this works. When you build your constraint table out, you go as far out as your decision variables, and then you go 1, 2, 3 more, and you build it out. So here our variables go to F, and then 3 more gets us to K. So we'll make this table all pretty. Label your headers LHS for left-hand side, sign, and then right-hand side. Now we can do our budget. So the sign, obviously, for a budget is less than equal, and if the client only gives us $250,000 only, it's pretty good, I think. Then you want to just stay under it. Obviously, the answer here is to invest all of it. It would be kind of sad if you have these positive returning investments to not invest all of it, but just to be consistent, we'll say less than or equal to, but the right answer clearly will invest all of it. And now, how do I know how much has been invested inside of each one, inside of this one? I just want to add up these numbers. And so to sort of copy the numbers to use the sum product, you can certainly do sum, but just to be consistent, let's do our ones across the board. That, when we multiply by the values, x1, x2, x3, x4, x5, that will multiply, it'll give 5 times 1, which is 5, then 5 times 1 again, so you're adding up each term. So a 1 inside the constraint table just kind of copies the number down. Then after you multiply by 1, which of course does nothing, and you add them up, you get basically the sum. So our left-hand side is going to be the sum product, and I can set this up of our variable cells. This way we're consistent every time. Put your dollar signs on now to do your referencing, lock this down. I use the keyboard shortcut F4. Of course, you can certainly come back in and type it in up here in the formula bar, whatever works for you. Then we do our budget, and we hit enter. And hopefully you agree, $5 here for 5 different investments is certainly 25. I don't need to format that as a dollar sign, but I certainly could. All right, so there's our first constraint. That's coming from the total amount to invest. Here come the 1, 2, 3 guidelines that we're going to need. Since there are only 3 more constraints, I will shrink my constraint table so that my spreadsheet looks pretty to just the other 3. We'll label it here. We have the muni bonds consist of 20% of the investment. Muni is 20%. We'll use shortcuts here. Oops, not 2%, 20%. No, at least 40% in tech stock, so 40% in tech, and no more than 50% should be high risk. So no more than 50% in high risk. Okay, let's see if we can take these constraints and actually put them in. Let's just do the first one. You'll see a pattern here. The municipal bonds consist of at least 20% of the investment. So first off, which ones of these are municipal bonds? Well, the only one, you got to read the labels here. The only first one is the LA municipal bond. So this is basically saying the muni bonds, or just the amount in X1, is at least 20% of the investment. So there's a couple different ways to do this. I'll do it right inside the table here. I need the amount in X1. Now remember, if you just want the amount, you put a 1 here. Amount in X1, I'll drag this formula down to get that, is at least 20% of the investment. All right, be careful. We saw this before. What does at least mean? Greater than or equal. This is a little tricky. English is a tricky language. At least a certain number means greater than or equal. So the amount in X1, notice the dummy numbers are really helping me see that here. The amount that I put in X1 has to be at least 20% of the investment. That's a calculation, right? 20% of the investment. And you can type it in, or you can link to the other one. Doesn't quite matter. Maybe I'll link it just so I don't have to copy it. But you can do a calculation on this right-hand side and have it be a number. And that's okay. Here, the one thing about this is that the investment, we know the investment is going to be the total amount because every single investment has a positive rate of return. So clearly, I'm going to put all my money into one of these investments. But I'm going to meet the requirement now that this number has to be at least 20%. So 20% of the investment, you can do in Excel, you can do it offline, maybe you can do it in your head, is going to be $50,000. So I need whatever goes into here, it has to be at least $50,000. That one hopefully is okay. let's think about the other one, the second constraint. At least 40% of the investment is placed in tech stocks. Now be careful here, it's not immediately obvious which ones are tech stocks, but Thomson Electronics, that is a tech stock. So maybe I'll label these here just to be super clear. That's a tech stock. The third one, aerospace, this is a tech stock. And Palmer Tech, I guess that was a little more clear. These are also tech stocks. So you need to know how much is going into the second, third, and fourth. When you just want the amount, you put a 1. So we're getting this nice pattern here of 1s. So how much is going into tech stocks is really saying how much is going into the second, third, and fourth investment. We drag this down. It's 15. Again, in your head, 5, 5, and 5. These dummy numbers keep being very helpful. We want to do at least, we've seen this before, at least is greater than or equal. And now we want 40%. Again, maybe you can do this in your head, but let's do 40% of our investment. You could type out 250 with 3 zeros, or I'll just keep clicking to it. The less numbers that I click inside there is perfectly fine. You could do this in another cell. Doesn't matter where you do it, but at least 40%. Last but not least, I have to do my high risk. No more than 50% of the amount invested in muni bonds should be high risk. Now, this is interesting. No more than 50% of the amount invested should be high risk. Let's think about, let's break that down for a second. Pause the video, see if you can work this one out. Half of this, the challenge is not always the Excel part, it's just the deciphering part. All right, so what's the high risk one? That is X5. That's the only high risk one that's there. So this constraint says that whatever we put in X5, it should be no more than 50%. So that's got to be less than or equal, less than or more part, of 50% of means multiply, the amount invested in muni bonds. Well, what's the amount invested in muni bonds? That's just X1, how much we put in muni bond. So this looks like this. You can probably put this in, we'd like to put numbers on the right-hand side. So what I'm going to do is, and we've seen this before, I might subtract this off, just move it to the left, and be less than or equal to 0. As a friendly reminder, when you work with inequalities, equations with less than or equal or greater than, everything's normal. You do everything like you would with an equality, with one exception. If you multiply or divide by a negative, the sign switches. Here I'm just subtracting things to the other side, so that the sign is still less than or equal to. And so now I can go over back to my constraint table, and I can put this in. Just be careful, the coefficient on X1 is negative 50%, and then the coefficient on the X5 term is 1. All right, so let's go do that. So just be careful. The coefficient on X5 is 1, and the coefficient on X1 is negative 50%. I'll copy the formula down for my left-hand side, and I will have my sign be less than or equal to 0. You absolutely could do it, I guess, with the original way and just say like 1 over here is less than or equal to 50% times one of the variables, I guess. But it's just not consistent with the way we do it. I'd rather a consistent approach every time. There's certainly more than one way to solve these problems. However, the answer will not change no matter how you set up your spreadsheet. So do this in a way that makes sense to you. But notice once in a while, if you get a tricky constraint, you got to come off on the side and kind of work it out. And that's okay. All right, so we have our budget. We have our 3 constraints. We have our wonderful 5 variables. By the way, if you're using Microsoft Excel to do these problems, Microsoft Excel can handle up to 200 decision variables. So here 5, even though it's getting larger, is still relatively small. And I think we're all set. Let's try to do it. Let's go to Solver here. You can kind of play the old-timey experienced boss and see if you can guess the right answer. Sort of plug in different numbers of time. Let's go right to Solver and let Solver do it. All right, here's your Solver parameters. And your box may look a little different if you have a different computer, but everything's still looking for the same things. What is my objective? What is the thing that I actually want to maximize? So I select the gray cell. Color coding helps keep things consistent. I want to maximize it. Yes, maximize return. Don't minimize your client's return. They will not be your client for much longer. What are my variable cells? And hey, now I have 5 of them. This is the whole part of this problem. Also the financial application. I have 5 variables. That's okay. Highlight all 5. Subject to the constraints. So let's add these in. I can't batch upload things that are not next to each other, so I'll do this sort of one at a time. I add the constraint to the left-hand side, less than or equal to the right-hand side. and I hit add. Now I have two constraints that are both greater than or equal, so I'll batch upload those two. I'll just do those together. And then I'll add one more, and I'll do my 2.5 less than or equal to 0. So I click around as we go. I hit OK, and I just give everything a quick check. Do I have my objective? Do I have max? Do I have my variable cells? Do I have my constraints? Do I want the variables to be non-negative? Yes, you certainly shouldn't put negative dollars into any investment, into any allocation. So I select my solving method, just swap that down to simplex LP, and I hit solve. And I get the ding of happiness. Solver has found a solution. All constraints are satisfied. So I hit OK. I have these pound signs. Hopefully, if you haven't seen this before, that just means that your columns are too small, partially coming from the fact that I didn't remove the decimals. So if you ever get those pound signs, just expand the columns. And here we are. So let's practice reading this. This says that I should invest $50,000 into X1, which is the LA Muni Bond. So remember the constraint said that I had to do that. X2 and X3, nothing. I like this when it tells you to come back with nothing. It's a little challenging as a consultant to tell someone not to do something. So here it is. So it says don't invest anything in X2 or X3, the Thomson Electronics or the United Aerospace. And then take most of your money, put it in X4, the Palmer Tech, which is nice. And then X5, $25,000 goes into the high risk. And you can check that you're staying under budget. If you add up all these numbers, you get $250,000. The Muni, the 20%, we're putting $50,000 in. So the minimal that we need, and the rest is going into tech and high risk. So very nice. So that works out kind of nicely. Again, you could write a nice summary sentence here that would satisfy this, and I sort of leave that to you to work out. But how would you present this back to the client? How would you defend your assumptions? How would you explain where the numbers came from? This is it. So your actual return is $20,300. Again, you can play, some people just don't appreciate what Solver's doing. Play the role of sort of the human investor, take a guess, see if you can beat or get anywhere close. And of course you cannot. And if you do get higher, sometimes students come back and say, I found a higher number, but then they didn't satisfy the constraints. So not only do you have to get a high number, you got to satisfy all the constraints that are required by your client. All right, so great job on this video. We'll see you next time.